Windows API has always seemed like this cool cryptic thing that allows you to hack the computer and stuff, and I had always wanted to learn it but couldn't find out good resources on it. Does this sound familiar? Handmade Hero is probably the best place to learn this topic, but the videos are very long, so in this tutorial series, I'll help you learn about the Windows API in the shortest time possible, and I'll deliver you all the knowledge that I have accumulated by watching the Handmade Hero series, and also by doing things myself. People may say that Windows API is difficult, but I organized my 3 steps tutorial series in a fail-proof way, so everyone can learn it. In the first step, I will show you some easy and interesting things, so you can get used to using the Windows API, like making a keylogger, manipulating the memory of a process, open a file dialog, and many others. In the second step, I will show you how to open a window, and even though this process is kinda difficult, you will be able to go through it with ease with your prior experience. And this will give you the knowledge to make a game without using libraries. This knowledge is more useful than you think because even if you will probably use libraries in the end, you will be able to debug them easier. Now, you will basically have enough knowledge to learn more yourself, but in the third step, I will show you some more advanced interesting things to keep you motivated. You'll also have homework, and I made a special Discord channel where you can ask me questions and post your homework. So make sure you watch till the end to get your homework, and join my Discord channel to post it. First of all, what is the Windows API? Simply put, the Windows API is the API of the operating system, and it allows you to create a Windows application. Imagine you create a Hello World program that writes something to the console. How is Cout implemented under the hood? Well, it calls some Windows functions that tell Windows to write some stuff to the console. So basically all the C++ libraries are implemented using the Windows API, and this implementation is called the C++ runtime. Now let's include Windows.h to access the API. Windows.h defines these 2 macros that are annoying. So you could just do this, but there is actually a proper way of removing them, and it is to define no min max before including Windows.h. And there is one more macro. If you define, and I'm not making this up, Windows 32 lean and min, Windows will include less headers to help speeding up the compile speed. Let's now use our first function, MessageBox. Whenever you want to use a Windows function, you search for its documentation on Microsoft's website. It tells you all the things you need, and even in what DLL it is located. I'll explain this one myself for you. First of all, you will see that there are 3 versions of this function, MessageBox Simple, MessageBox A, and MessageBox W. All the functions that take strings have these 3 versions. Basically, the one ending in an A uses normal strings. The one ending in W uses Y strings. The one without a letter is defined to be one of the other 2, depending on the configurations of the project. There are also some functions ending with an X, and that just stands for extended version. Anyway, this function will create a pop-up like this. Let's look at the parameter types. You can ignore these things with underscores. They are just used for some Microsoft tools or something. Now, HWND means handle to a window, and you can just put a 0 here. LPCSTR means long pointer to C string. If you don't know what a long pointer is, don't worry. You can look it up if you want, but it is not relevant nowadays. Basically, anything starting with LP means that that type is a pointer. So the second parameter is the content, the third is the title of the window, and the last one is the type of the window. The type just starts with MB, meaning message box, and the function returns what the user clicked. This is the code in action. There is one more thing I want to show you. There are many times when you have to complete these big structures with data. Sometimes, the first member has to be the size of the structure, and it is like this to help Windows to determine what version of the API you are using or something, but in practice it probably didn't help anyone. Anyway, you can just do this, and this will set the first member and leave all the others to 0. If you didn't know about this trick, I'll release a C++ tricks video soon. Now, before I give you the homework, I'll just mention that in the next video I'll talk about keyboard input, and you will be already making a game, so subscribe to not miss that out. But for now, your homework is 1. Take a look at the MessageBox documentation to get used to it, and also take a look at other functions here that look interesting. And 2. Try to make a small decisions game using message boxes. After I had learned some basic programming, I realized that I had enough knowledge to implement a snake clone in the console. I just had to make an infinite loop, clear the screen, throw the snake, and handle the user's input. The only problem was that scene would just block the game. I even tried moving it into another thread because I wasn't able to find what we are going to learn here today. We will also learn what this strange twin version of the main function is, so let's get into the tutorial. getAsync key state, while it has a complicated name, allows you to get instant information about the keyboard. Take a look at this code. It will print A every time I press the A button. Okay, now maybe you want it to behave like typing. If I open a notepad window and type, you will see that as I hold the key, it will register once and then repeatedly, but slower. To do this, you just have to check if the first bit of the return value is set. I'll quickly mention that later, when we'll be opening our own window, we will use something different for input, but now let's make a keylogger. A keylogger is a virus that runs in the background and registers every key pressed in order to hopefully steal some passwords. Don't steal passwords. Stealing passwords from other people is illegal unless other people give you the permission to do so. In that case, I don't know why they have passwords, but who am I to judge? So we will just iterate through all the 256 possible values, because if you look at the documentation, all the possible inputs are less than 256. Let us just use the uppercase ASCII code, while other keys have special macros starting with vkey_, meaning virtual key. Note that you can also get the mouse clicks with this function. This is the result, and you'd probably want to send the output to a file. Now, how you do make the console disappear? If you try to debug a Windows application, you will see that main is not actually the entry point. Main CRT startup is the entry point, and basically the C++ runtime will do some initialization stuff first, and then it will call the main function. So let's take a look at this call stack. NTDLL is basically the Windows kernel, and it calls into, well, another Windows kernel stuff. Then we finally get to the C++ entry point that will eventually call into our main function. It is possible to write this function yourself, and that means no to a lot of C++ features. You can check this video if you are interested in that, but right now we want something else. We want to tell the C++ runtime library to use the winmain as the entry point. This is the entry point of a graphical application in Windows, according to Windows documentation. If you use CMake, this is the line that you want to add, and if you just use a Visual Studio solution, this is the setting that you want to change. Now, since we won't be able to see a console anymore, let's just use what we learned in the previous video and make a message box appear. Awesome. Now, you might be wondering, what all these parameters are? Well, the first one is a handle to the instance of your program. The second one is not used anymore. The third one is the command line argument. And the final one tells your application how to open. It is basically this setting from here. We will return here when we will be creating our own windows. In the next video, I'll mention how to also open a console with this setup, so subscribe to not miss that out. So now your first piece of homework is to add the winmain function to the keylogger, and log the keystrokes to a file to complete it. Don't forget to add some more keys here, and also make a way to be able to exit the program. Use the Microsoft documentation to look at all the possible keys inputs. Now for the second homework, you'll have to implement a snake clone or just implement some movement in the console using what you have learned today. You can use systemcls to clear the screen. Don't forget that you have to include cstdio, and also, to make the player move to desired speed, you can just call sleep, because that would also block the input. So use this template that I gave you in the description. In the next video, we will learn some more things about the console. For example, how to remove this weird flickering thing and other interesting things, so make sure you subscribe and stay tuned to not miss that out. I hope you enjoyed my WinAPI tutorial so far. If you want to support me, you can do that directly by joining my channel, and you'll have access to the tutorial videos a little earlier as thanks. But don't worry, they will always remain free, and I'll still upload them fast. So if you don't afford that but still want to support me, don't forget to share my videos and check out my channel. Let's continue our journey into Windows API and learn some more about manipulating the console. And also, learn about handles. So, what is a handle? Well, think of it like a special variable that Windows gives you to refer to a Windows object, and there are all kinds of handles. For example, you need a handle to a process if you want to read from that process's memory. You ask Windows for the handle, along with permissions, and after you are done, you tell Windows that you don't need it anymore. For now, we will be doing something much easier. We just want to access the console's buffer. To do that, we need to call this function. Then, by calling setConsoleTextAttributes, you can change the colors of the next letters to be displayed. The second parameter is the color code, and you can just search it on web or just open a console and type color ? To get a table describing all the codes. Before we move on, I'll just mention that these are the lines that you need in order to open a console when using WinMain. This is nice because now you can choose if you want a console or not programmatically. Now, I hope you did the homework from the last video, because now we will learn some new things to improve on it. So, systemcls seems to be quite slow. Instead of cleaning the screen, you can just redraw over it. Using the setConsoleCursorPosition function, you can set the right cursor at the beginning and redraw your game from there. Using setConsoleCursorInfo, you can also get rid of the cursor indicator. The result looks like this, and your first homework is to add these improvements to the game you made in the last tutorial. Now I have something else to show you. It is also possible to set your own console buffer directly or write to the current console buffer using Windows API, using these functions. Your second homework is to experiment with these functions and explore the documentation yourself. See if you find something interesting that you can use for your project. Why do you think scene.get doesn't work anymore in the second version? And by the way, I'm expecting you to glance at the documentation for all of the functions that I show you. And you are doing that, aren't you? Also, if you are brave enough, you could try to implement your own printf function. I think that could be a great exercise. Okay, in the next video, I will talk about errors. Functions in Windows can give errors. Let's take a function from the previous video. getConsoleCursorInfo returns 0 if it fails, as many other Windows functions do. Errors can be both your fault or Windows' fault. For example, you could forget to pass the correct handle. It is worth knowing that not all functions return 0 on fail. getStdHandle returns an invalid handle value on fail. That is a -1. Now, to get information about the error, you need to call getLastError. This works with all Windows functions that I know of, and it will return an error code. Now that error code might not be that useful, so let's convert it to a message. The process is not very interesting, but you can read about this function if you want to. So, if getLastError returns 0, that means that no errors occurred. If else, you have to use this function that formats the message for you. The nice thing is that passing the formatMessageAllocateBuffer flag allocates the right amount of memory for you. Don't forget to call free on it after you use it though. And that is it. The homework for today is very simple. Just check the game that you have been implementing in the last videos for errors, and if any occur, display them in an error pop-up like this one. Also, make sure to look at the documentation for some more interesting things. If you learned something useful today, don't forget to show some appreciation by sharing this video and subscribing. Some functions inside the Windows API seem scary because they are very big. In reality, most of the parameters are optional, so you shouldn't be scared. Let's work together to a function like this. getOpenFileName is a good example. It seems simple because it takes only a parameter that is a struct, but if you take a look at it, you quickly realize that you have been totally trolled by Windows. The functions opens a file dialog, and I don't know about you, but I think that is really cool. So let's take a look at the documentation. Microsoft suggests us to use something more advanced here, but for our purposes, it is totally fine. The function takes one parameter and returns non-zero on success. Let's look at the structure now. The first parameter is the size of the structure, as I explained in the tutorial 0, so we can just initialize it like this. Now, if you start reading through the other parameters, you'll quickly see that most of them are optional. For example, we don't have an owner for this window, so we can just ignore this parameter since we already filled it to null when initializing the structure. The parameters that we care about are these. The LPSTR filter specifies filters for the file types, and you have to first pass a display name, then a filter for each file type you have. If you don't want to use this parameter, you have to pass this. Then you need to specify a title and a buffer for the user to write into, and that is it. Now, if you want these tutorials to actually help you and not just watch them for some quick dopamine, it is important to do your homework. Your homework for today is to make a simple abstraction over this function. I recommend using a function over a class for this. And explore some of the functionalities in the documentation yourself. I'm trying to make WinAPI seem easy, but in reality it is easy only if you start gaining experience using it. For example, the first two lines here are the incorrect way of doing things, while the other two are the correct ones. There are also some things that don't work anymore. So I want you to try stuff here and experience the inconveniences of debugging the Windows API to gain valuable experience that will help you in your future programming career. And as always, don't forget to share your experiences in the WinAPI channel on Discord. See you! Let's learn about files. In this video we will implement three functions: get file size, read entire file binary, and write entire file binary. You'll also learn some low-level insights, so let's start. Now you might be wondering, why read or write an entire file? Well, this pattern happens to be useful in game development. It is very efficient, simple and less error prone. You can for example take a struct that is relevant to the game and write it entirely and later read it back to basically save and load the game state. I have a library that is based on that and I link a video on it here when it will be released. Let's start with the simplest function. Get file size. First we need to get a file handle. If you remember from day 2, a handle is just a Windows object and it refers to a file in this case, but it can refer to other things like a console buffer. First we specify the file name, then we specify that we want to read from the file. Then we get to this weird parameter called share mode. You see, file operations are atomic. So one process can write into a file and the other one will have to wait until it can also write into it. If you do multiple operations however, the two processes will fight over the file. You don't usually want that. So whenever you get a handle to a file, you can specify that you don't want other people to mess with it. In our case, we can specify file share read, meaning that others can read from our file, but not modify it until we are done. And by done, that means closing the handle. The next parameter can be ignored. Then we specify that we want to open an existing file, and the last two parameters are again not interesting. Now we just have to check if the handle was valid. If not, some errors occurred, and if you want more details, just call getLastError and look at the documentation for the possible cases. Finally, we can call getFileSizeX, and if it doesn't fail, we can return the size. Don't forget to close the handle. As a quick note, closing the process will automatically close all the handles that you created. Now let's implement reading and writing to a file. We are going to assume that the file can always be modified by outside, because it can, so you should take care of that possibility. So getting the file size, then allocating a buffer of that size, and then resizing the entire file into a buffer is not a safe operation, because the file size could have been increased in the meantime. So this version of the function will allocate the memory for you and make sure it won't allow anyone to change the file until it finishes filling the buffer. I'll take a vector of bytes as a memory buffer. Now we can't reuse the function from above, because we want the handle to remain open. Remember, since we specify file share read, no one can modify our file until we release the handle. So after we get the file size, we can finally call read file. We pass the handle and the buffer, then the buffer size, a pointer to a variable where the number of bytes read will be stored, and the last parameter can be ignored. Now we check if it didn't fail, and we can also check if all the bytes were read. Don't forget to close the handle. Now let's implement write entire file. The process is similar, but we have to pass the createAlways flag when opening the file. This means that the function will open or create a new file if needed. There is also the option createNew that will create a new file or fail if it already exists. Interesting. Next we check if the size is not 0 and we call writeFile, checking if you wrote all the bytes, and don't forget to close the handle. Now it's time to talk about your homework. Your fourth homework is to implement an API to allow the user to safely size his own buffer and read an entire file. You could for example make a struct, and once you call the open method, the handle is created and the access is locked, so an operation like this is safe. You can also add a size to the read entire file function, and if the function does not read exactly the number of bytes specified, it fails. Your second homework is to take what you have learned in the last lesson and combine it with this one. So basically open a file dialog, open a file, and do something interesting with it. Alright, we are getting close to more interesting stuff like the window opening lesson. If you start to find the things here difficult, a trick to help you is to have an accountability partner. So basically, take a happy friend and slap him with this tutorial series, so now you both have to learn it together. I think it is a win-win situation because we will both motivate each other to learn it and I'll get more views, so share this to a friend who is happy and you want to make his life more difficult. In the next tutorial, we'll learn about memory mapping. Let's talk about file mappings. This is not something that you will do often, but it is valuable to know because this concept is used in many things, including graphics programming, and it is the perfect introduction to virtual memory, which we'll talk about for a few videos. So let's go! So a file mapping essentially maps the content of a file into memory, allowing you to directly access the file's content using a pointer. This means that if you write to that memory location, the file will be modified, and if others write to it, you'll be able to see that. If you know something about pointers, you probably know that they are supposed to point into RAM. So how can a pointer point to a file that is stored on disk? In order to understand this, you have to learn what virtual memory is. I already explained this topic in this video, so I'll quickly reuse the explanation from there. So, do you remember when you learned about pointers and people just told you that they are addresses in RAM? Well, this is actually a lie. You see, there is a level of indirection here. This is all the memory that your program uses, and it is divided into blocks called pages. A page's size differs in each PC, but it is usually 4 kilobytes. Memory addresses are actually pointers to these pages that are later stored in RAM. The program can just read these values, but under the hood, the operating system can move pages wherever he wants in RAM, or even store them in the hard drive. If you allocate some memory but not write to it, the operating system can even pretend that that memory region is allocated, while in fact it isn't. Okay, now whenever you create a file mapping, that doesn't necessarily mean that the pointer will point to the hard disk. The content of the file will probably be loaded into RAM and copied back into the file when it is changed. This is because the RAM is way faster than the hard disk. It is up to the operating system to do this, and if you choose to map the file that is bigger than your RAM, it might not do it at all, or most probably, just do it in smaller segments. Now let's look at some code. We first create a file, as we did in the last tutorial, but I specified that I would want others to also be able to read and write from it, while I have it open. Then I call create file mapping. This will actually create another object, but not map the memory yet. For this we have to call map view of file. Note that when you call create file mapping, you have to pass the maximum mapping size. And because it's an old Windows function, they split a 64-bit parameter into two 32-bit numbers. Also, note that when you call map view of file, you can specify any offset for the file, and a smaller size if you want. Finally, note that unlike create file A, create file mapping A returns null on failure, not invalid handle value. Now we have our pointer, and here we first write to it, and then we will read from it on a loop. Let's open the created file and modify it. The first thing that you can see is that there are many blank spaces, and that is because we set the size of the file to 100. As you can see, modifying the file will also modify the data in our program. The homework for this video is to make two programs that communicate with each other using this mechanism. You could use two files for this purpose. Don't forget to take into consideration that program 1 might read the content from program 2 before program 2 finishes writing all the content. I will also mention that the guy who made the Handmade Hero series just released an interesting video on this topic, so you might want to check it out. But now, let's learn some more about pages in the next video where we will be allocating memory. Last time, I told you that a page is the mapping between the pointer and the physical RAM. Pages have their own flags. Those can be read, write or execute, for example. For your PC, your data is just numbers, so you could execute some code where there is just random data, not code. This is where pages come in handy. If that page doesn't have the execute flag, the CPU will detect that and raise a page fault signal. To allocate memory, you have to call virtual alloc. There are also some other versions of this function, but we don't care about those. You have to understand that this function has a different purpose from the new or malloc in C and C++. Virtual alloc will allocate pages for you, and hence the minimum allocation size is the page size, which is rather large. So if you pass a smaller size, it will just be rounded up to the page's size. For allocating smaller random things, there is another Windows function called heap alloc. Basically, all new or malloc do is call virtual alloc at some point, and then have a data structure to manage the memory and give it to the user. I might talk about implementing your own memory allocator in the future. Coding time. calling getSystemInfo will give us various information, including the page size. I also made a roundup function that will round up any number to be a multiple of the page size. The first thing we do is call virtual_alloc. Notice that you can specify at what memory location to allocate the memory if you want, but this will fail if that memory region is already used. Also, that memory region will be rounded down to the page size. Next, we pass how many bytes to allocate, but remember that this number will be rounded up to be a multiple of a page size. Then we pass the memReserve and memCommit parameters. memReserve will just tell Windows to keep in mind that we need those pages, but they will not be mapped into RAM until you call memCommit. In this case, we both reserve and commit at the same time, but you can do some powerful things with these pages. For example, in this video, I created a vector data structure that grows without having to reallocate the memory by first reserving a lot of memory and then committing it. Okay, now we write to that memory and read it back. Remember that the size will be rounded to be a multiple of a page size, and on my machine, a page size is 4096 bytes. So that is why we can access a bigger memory location than specified. Let's run it. You can see what my page size is, you can also see the roundup function working, and finally, you can see that the allocated memory is working properly. To deallocate the memory, you have to call virtual_free. Finally, I have one more thing to show you, and it is the virtual_protect function that will change the last flag from the virtual_alloc function. Again, you should look on your own at these flags, because there are some interesting things here. But for now, we will change the protection of these pages from read-write to no access. Any attempt to access this page will crash the program. Why would you want to do that? Well, during development, instead of freeing the memory, you can mark it as having no access, allowing you to catch some potential bugs. If you access freed memory, it is technically possible to not always have your program crash. So, by making it as no access, you can be sure that any access to it will crash the program. There is also a page guard option, but for this one, it won't crash your program. You have to catch its error signal, and I haven't personally looked much into it. Okay, your homework for today is to play with these new functions and parameters and read the documentation to see how they work. Not very interesting, I know, but now we will be reading another process's memory. See you in the next video. Last video we talked about allocating memory and pages. Let's use this knowledge today to read and write another process's memory and even take a look at how to implement something like cheat engine. So, as I explained last time, each process has a page table associated that tells the CPU how to dereference pointers. Now each process has its own unique mapping. This is also called virtual space. For some things, the operation system will reuse pages. For example, when loading a DLL, the operating system can load the DLL functions only once in RAM, regardless of how many processes use that functions. The mappings can and will probably still be different, but the addresses will point to the same place. Now, what happens if one process wants to read from another process's memory? Well, since they have different mappings, you can't just read from another process's memory. You have to ask Windows to copy the memory content in your own virtual space. Okay, so how can we do that in practice? Under day 8, in the repo associated with this course, I created a victim process. It has some data, and it will first print its address. Then it will wait for us to press enter, and finally, it will print the content of the data inside an infinite loop. This will allow us to see if it was modified. Now we will look at the hacker process that will attempt to modify the victim's memory. The first thing that we have to do is to find the victim process. And there are a few ways we can do this. I chose to find the process's ID using the process's name. So the process ID, or PID, is just a unique number assigned to each process. If you open Task Manager, you can take a look at each process's ID from there. I wrote this helper function to get it programmatically by program name. You don't have to understand how it works, but basically, I'm just iterating through all the opened processes and searching for the desired process name. Now, in order to read or write from another process's memory, we need a handle to that process. Luckily, it is not difficult to get that. We just have to call openProcess. The first parameter is a desired access, and we can just tell Windows to let us do whatever we want with our poor victim by specifying process all access. Now, of course, this would fail if you try to open a higher privilege process than your process. because then you could just DLL inject it and take over the victim's PC. So this is why there are so many flag options here, because Windows might allow you to specify some of them, and might not allow you to use others, depending on the process that you are trying to open. As always, you should be also taking a glance at the documentation on your own. The next parameter can be false, and finally, we can pass our PID. The functions return 0 on fail, which is strange because some other functions return invalid handle value. But anyway, we'll just check for this possible error. Now we can finally read and write to the process's memory. Read process memory does exactly what it says it does. The first parameter is the handle, then the address we want to read. This address is in the victim's memory space. I will just read it from the keyboard. Next, you have to pass a buffer for the data to be read into, and the size of that buffer. Finally, in the last parameter, Windows likes to report back to us the number of bytes read, as it happens in many other functions. But fortunately, we can pass null pointer here, and Windows will ignore it. Be careful, because not all functions allow you to pass null pointer for this parameter. Now we print the data and then we change it to 69 MAO. Write process memory has exactly the same parameters as the function above. Both functions return non-zero on success, and I say non-zero because the value returned is actually an int, not a bool. Yes, it looks strange, but keep in mind that this API has to also work for C, where you don't have bools. Let's test it. We first launch the victim. Let's copy the memory address and start printing the data. Now let's open the hacker process. Once I paste the memory address, you can see that the victim's data was changed. Okay, now there is still a problem here. Let's say you want to scan the process's memory. You could start reading to the process's memory, but that means searching for 2 to the 64 addresses. For reference, if you could scan 1 million addresses per second, it would take more than 500,000 years to scan all of them. Well, in practice, the virtual address space is smaller than that, because it is useless for Windows to allow you to access that many addresses. So Windows doesn't use all the bytes for optimization purposes. But it is still a big number. So, how can you make something like Cheat Engine? Before I tell you that, I want to quickly congratulate you for making it this far into the tutorial series. We are 2 more videos away from finishing part 1, and don't forget that in part 2 we will learn to open our own window. So subscribe to not miss that out. Okay, so let's look again at this drawing here. This might give you a hint to what we can do to scan a process's memory. We have to ask Windows to tell us what are the pages of that process. Almost any address can be mapped by a process, but in practice, a process doesn't need terabytes of RAM, so only a few pages will be mapped. We can ask Windows to give us a list of those pages. In virtualscanner.cpp, I have done exactly that. The program starts like the hacker one. Here I am calling, however, the scan virtual pages function that was written by me. Let's see how it works. First, I'm getting the page size, as I did in day 7. We will use this to display stuff later. Next, I have to create this memory basic information struct. Scanning the virtual space of a process works like this. You have this function called virtual query X. Unlike virtual query X allows you to scan other processes' virtual space rather than just your own. This function gives you information about the next page's range, starting from the base address. So, for example, if I put the base address 0, the function will give me the first range of pages. And by range of pages, I mean contiguous pages that have the same flags. So if you allocate, let's say, 1 GB of memory, for example, Windows will give you some continuous pages to fill 1 GB of memory. Now, to scan the entire process, you have to call this function inside an infinite loop, and increment the base size every time so you scan the next pages. And we will increment it by the region size. Now, remember about the page flags that I mentioned last video? We can check for these flags here. We want to search for pages that are committed and that are also read-write. Here we will be able to find the program's variables. Finally, I will display the region information. To see how many pages are there, I will just divide the region size by the size of one page. As last time, I will first open the victim and then the virtual scanner. One interesting thing that you will notice is that, as expected, all of the pages are aligned in memory to the size of one page. Okay, now your homework is to try to use this knowledge to try to make something similar to Cheat Engine. Now I will give you quick tips. First, don't scan the memory for the value of 0, because there are many zeros in one process. Also, just focus on one data type, let's say int, and remember that the data will be aligned. So if you scan 4 ints, you can scan every 4 bytes. If you are still unsure how Cheat Engine works, check out this video about my Cheat Engine clone. But now, we will learn how to load a DLL. Let's learn about DLLs in Windows. They allow for an easy way to add mods to our game, and they also allowed me to implement code reloading in my engine while the game is running. So a DLL is just like a normal program, but without a main function. It has some functions that can be loaded and used by other programs. So it is just like a library. It was intended for code reusing, but you as a game developer will benefit most from it because it can allow for easy modding, implementing hot code reloading, and also it allows you to split a big project into multiple components to speed up compilation time. You can rely on the C++ runtime to link statically your DLL to your program using DLL export and DLL import, but that removes a lot of flexibility. You can specify the DLL path, and if your program can't find the DLL, it will just terminate its execution. In order to use the Xinput API that allows you to use the Xbox controller, you have to load the DLL unfortunately. And if that DLL isn't found for some reason, you don't want your game to just not start. You want to be able to play it, but just without controller support. And yes, that can happen. There are multiple versions of Xinput, and you'd want to load the newest if possible, which is not available on older Windows versions. ImGUI had this problem, for example. It has controller support, and I sent a game to a friend, and he couldn't open it because he didn't have the last Xinput version. Okay, in day 9 of this tutorial series, I have 3 files. DLL.cpp that will create our DLL, main.cpp that is our program that will load our DLL, and also a header file that will have the function declaration from the DLL, so main can use it. In order to create a DLL using CMake, all you need to do is add this line here. In DLL.cpp, I have a function called foo that prints a message. I also have to specify declspec DLL export to tell the compiler to allow this function to be loaded from the DLL. You also have to specify extern-c that disables name mangling, so we can search for our function. If you don't know what name mangling is, well, C++ just messes with our function's name, so it can implement function overloading. But we don't want that here, because we want to find our function in main. There is also some extra stuff, but we'll look at that later. Let's look at main now. I will first press Ctrl-Shift-B to build all of the projects, including the DLL. The DLL will also be created in the same folder as our exe file. This is important because we now need to find this file to load it. To load it, we have to call load library A with the path to our DLL. If the function fails, it returns 0. Now we can call getProcAddress to get a pointer to the function from our DLL. A function pointer is just as it sounds like. But notice that I have this foo_t thing here. This is defined in command.h. Here I have the function declaration, and also I have this typedef. This creates a type for our function that I use to create the function pointer. Now notice that we have to repeat the signature of our function. And as programmers, we don't usually like that. So you can use this trick here that does the same thing as above, but you type the function signature only once. Okay, now if the function wasn't found, the pointer will just be set to null. If else, we can call the function. And if you run the program, we can see that it worked. A nice thing is that you can even debug your functions from the DLL without doing anything extra. You can imagine how this mechanism allowed me to implement code reloading in my engine. I just have my gameplay code in my DLL and I just recompile it, while the main program keeps all the memory relevant. You can modify a DLL while it is being opened by another program, so you have to make a copy of the DLL in order to open it, while also allowing the compiler to modify it. Okay, now to close the DLL, you have to call free library. But as with any other freeing related thing, this is done by the OS at exit. So you don't need to call this when your program closes. So what is this thing then? Well, this is called the DLL entry point, and it has a nice documentation. Basically, it is a function called when a program loads the DLL, unloads the DLL, or creates or destroys a thread. This is useful because you can initialize stuff here and also deinitialize stuff. So your homework is to play around with this. Try to print hello here and see how it behaves. Add a hello thread message here and see if you can make it appear on the screen by launching a thread in your main program after loading the DLL. Also, closing your program will also call this function because you are detaching your thread. So if you open your program here, you basically create a program that can be closed. Okay, so now we will be looking at manipulating a window, and after that, we finally will be creating our own window for our game. Welcome to the last day of part 1 of this tutorial series. Part 2 will be entirely dedicated to opening and managing a window. So yes, it is a long and difficult process, and this is why this video will be a gentle introduction to Windows in Windows. So pay attention because the next tutorials will become easy only if you stay with me for this video, and I also have an interesting homework for you today. So the first thing you need to learn about is what is a HWND, and HWND stands for handle to a window. And it is just a pointer, so just a 64-bit number. A normal handle is also just a pointer, but they created a special type for a window handle, so it is easier for us to know when the API refers to a window or another type of handle. So in day 10, in main.cpp, I first call this function. All it does is to open a pop-up window that will be our victim. It will open it in another thread because the function waits for the window to be closed, and we want to continue running our program while the window is running. As you will see in the next video, a window is not something that you launch and it exists. It is something that you continuously need to keep alive in your code. Now, some things that you should know about a window. We usually associate a window with a process, but a process can have multiple windows or no window at all. Any window has a position including in the Z direction that specifies what window is displayed on top of another. And they also have a lot of flags, like you can even make a window transparent and stuff, but we'll look at that in another video. Now I also want to mention that a window can have a children. A button, for example, is also a window that is child to a parent window. Now, when we'll be making games, we'll just have one window and make our own buttons. It is much easier than using the Windows API, but we will still need one parent window. Okay, let's return to coding. Now we need to get a handle to our window, and the easiest way of doing this is to call find window. This will find the window by title and will return you a handle to the window. You can ignore the first parameter. Now, with your HWND, you can do all sorts of stuff to that window. The simplest function that we can call is showWindow. The first parameter is a handle to the window, and the second is the flag specifying how we want to show our window. And there are also some other strange flags besides show or hide. Okay, next we'll change the Windows flags. To be more specific, they are called Windows styles, and there are so many that they have styles and extended styles. To get the current style, you call getWindowLongPTR, and it will return you a 64-bit number that is just a bit filled with the styles. I will use the XOR operator to swap the Windows styles border bit to essentially remove and add back the border to the window. Finally, we want to apply the style back to the window by calling setWindowLongPointer. As you can see, the window looks kinda strange without a border, so you shouldn't mess with this flag unless you know what you are doing. I am showing them to you for educational purposes. This is also how I made the Notepad window in my Minecraft in Notepad video, refused to get input from the user. There are many other flags like disabled, for example, as you can see here. There are also extended flags, but you have to use glw xstyle here and here to use those. getWindowLongPTR actually can return you some other info about the window, but you'll use those in another video. Next, to get the window size, we call getWindowRect. This will give us the boundaries of the window's drawing area. So it will give you the beginning point of your window and the end point. So to get the window size, you just have to subtract those 2 points. Now let's move the window around. To move it around, we have to call setWindowPose. Now this function can move the window, resize it, and also reposition it in the Z order. So if you for example only want to move it, you have to pass these arguments to tell the function to ignore the resize and Z order parameters. We have to do something similar for resizing the window, and to reorder it on the Z order. Finally, we can even place it as a topmost window, meaning that it will stay on top on all of the windows. So let's take a look. We can get the window size, and after we resize it, we can see that we get the new size. We can move it around, and we can place it on top. Finally, if we set it as a topmost window, it will never be occluded by another window. Finally, this is your homework for today. You have to make this window run from the cursor, and you have all the knowledge that you need to finish it. I'll just tell you that you need to call getCursorPosition to get a mouse position. The homework solution is also in the repo, but try to solve it yourself. Now share this video with a friend that likes programming like you, and subscribe because part 2 of this series is coming and you don't want to miss it out. See you there!